It helps to think of math as a universal language. And like any language, it has a grammar, a set of rules that make sure we all understand each other no matter what. Because without those rules, a simple math problem could mean two totally different things to two different people. And that would be, well, chaos. Okay, let's start with something that looks super simple. We've got one addition, one multiplication. Seems easy enough, right? But here's the catch. Depending on which one you do first, you're going to end up in two completely different places.
And here they are. If you add first, you get 28. If you multiply first, you get 22. Now, the math in each step is correct, right? But the final answers are worlds apart. So this brings up a huge question. How can math be this precise, perfect language if we can get multiple answers to the same problem?
This isn't a trick question. It's the whole reason we need a rulebook. To avoid all this confusion, mathematicians all over the world agreed on a standard order for doing calculations. It's not about what you feel like doing first. It's about having clarity and consistency every single time. So what's the solution? Well, it's a system called the order of operations. You might have heard of it by its acronym, BEDMAS. This is the official rulebook, the thing that guarantees that everyone, no matter where they are, will get the exact same answer to our little problem. So how does it actually work? Well, it's basically a hierarchy, a clear pecking order that we have to follow. In some parts of the world, you might hear it called PEMDAS, but don't worry, the rules are exactly the same. It's our guide through any math expression. Now, the most important thing to get about BEDMAS is that it's not 6 different steps. It's really a 4-level hierarchy. At the very top, you've got brackets. Anything in brackets gets done first, period. Next up is exponents. Then, and this is key, on the 3rd level, we have division and multiplication. They're partners. They have the same priority. And on the bottom level, we've got their partners, addition and subtraction, who also share their priority. This brings us to a really, really important tiebreaker rule. What happens when you have those partners, like multiplication and division, in the same problem? Which one do you do first? The rule is simple. You just work from left to right, just like you're reading a sentence. And you can see just how much this matters. Look at this. If you ignore the rule and go from right to left, you get an answer of 2. But if you follow the rule and work left to right, divide first, then multiply, you get 50. I mean, that is a huge difference. So that left to right rule, it's absolutely non-negotiable.
Okay, so let's up the ante a little bit. What happens when we throw negative numbers or integers into the mix? The good news is the rules of BEDMAS don't change at all. We just have to be a little extra careful with our plus and minus signs.
All right, now this one looks a lot more intimidating, doesn't it? We've got exponents, we've got brackets, negative numbers, 4 different operations. It's a lot. But if we just trust our BEDMAS rulebook, we can break this down into a bunch of simple, easy-to-handle steps. We just follow the hierarchy, step by step. First up, brackets. Inside, we have 4 times -2, which gives us -8. Next on the list, the exponent. -8 squared is a positive 64. Okay, now from multiplication and division. Remember, left to right. So 64 divided by 2 is 32. And 6 times that -8 we found earlier is -48. Last step, we add them up. 32 plus -48 gives us our final answer, -16. See? Not so bad. Okay, we've got the rules for how to calculate things. Let's switch gears and look at another part of math's language, how we compare things. And this is where ratios come into play. They're all about showing the relationship between different amounts. Simply put, a ratio just tells you how much of one thing you have compared to another. And just like with BEDMAS, order is everything. A ratio of apples to bananas is totally different from a ratio of bananas to apples. The order really matters. Now, you're going to see ratios written in a few different ways, but they all mean the exact same thing. So whether you see a colon, the word to, or a fraction, it's all communicating the exact same relationship. In this case, for every 4 bananas, we have 3 pineapples. Here's a classic example you see all the time, a part-to-whole ratio. In this class, we can compare one part, say the 12 boys, to the whole group of 30 students. That ratio would be 12 to 30. We could also do a part-to-part ratio and compare the 12 boys directly to the 18 girls. So this is where everything we've talked about really comes together. We can combine the strict rules of BEDMS with the power of ratios and percentages to solve practical problems, the kind of stuff you actually run into in real life.
Let's dive into a scenario we've all been in. You're shopping, you see something on sale, but you know you still have to pay tax on it. Well, the order you do these calculations in, applying the discount and adding the tax, is absolutely critical to figuring out what you're actually going to pay at the register.
You have to do this in the right sequence. First, the store takes the discount off the original price. It's only after you get that new, lower price that you can figure out the tax. You can't do it the other way around, it just won't work. Okay, step 1. We calculate the 25% discount. Well, 25% of $80 is $20. So we subtract that from the original price, and that brings our subtotal down to $60. That's our new base price. Then, for step 2, we add the 13% tax. And, this is important, we add it to that new price of $60. 13% of 60 is $7.80. We add that on, and we land on our final price, $67.80. And this is really why all this stuff matters. Having a shared set of rules like BEDMAS isn't about making math harder. It's the exact opposite. It gives us the power and the confidence to look at a complicated problem, break it down into simple pieces, and solve it, knowing that we're going to get the right answer. So I'll leave you with this final thought. Math gives us this clear, undeniable language to solve problems. But what about the rest of our lives? What are the other unspoken rules, the social grammar that we follow every day to bring a little bit of order to all the potential chaos? Thanks for watching.